Alrighty, hello everyone and welcome back. This is my submission for the Game AI assignment. So, for my assignment, I went ahead and added in my parkour Godot project, yes, this is Godot, um, I added this Colossus. So, pretty ominous here with the spotlight. We break line of sight because we don't want it to see us just yet. Oh. So essentially what's happening here is that this is a Colossus that is kind of like passive. Just we'll go over the behavior, broad strokes here. It's passive until you get close, and then it wakes up. It'll start sweeping with those searchlights looking for you. And then once it actually spots you, it's going to come after you. So if I'm far away, it's going to launch water attacks at me. It's going to try and close the distance. It's going to get close range so it can swing. If I break line of sight, it's going to go and search around, where it last saw me a little bit and then enter its passive mode. And if I hurt it enough, it's going to stop charging and it's going to start backing off and shooting instead and kind of take a more evasive approach. So that's the behavior. The way it's done is a mixture of a hierarchical state machine and a utility system. So essentially, the state machine is deciding, first of all, huge high level, what state am I in? But more importantly, which actions are legal? And then the utility system is going to decide which of those legal actions do I want to do the most, and then it's going to do it. So for the states, it's things that you can only really be in exactly one of at a time. So death has to override what's running. So inside of its combat, shoot versus swing isn't a state or a different mode. It's just a comparison that kind of changes comparatively with distance, with health, and what's off of cooldown. So combat is just one single state, and it doesn't necessarily pick attacks. It just hands control over to a reasoner that's going to score the 5 actions and run the highest one. So essentially, these behaviors are coming from 3 parts. They're coming from the perception layer, the state machine, and the utility reasoner. None of them call each other, but they all read and write to one object utilizing the blackboard pattern, and every field in that object really only has one writer. So perception is what kind of wakes it up. Each eye checks whether the player's in range, whether it's inside of its cone, and then it kind of writes that to a blackboard along with a confidence value that's going to climb while it can see me and fall while it can't. So the searching kind of comes from that fall off. So confidence doesn't necessarily snap to 0 when I break line of sight. It decays over a few seconds. And that state machine is reading the value on the way down. So the state machine essentially handles the modes. It's hierarchical because a state can contain another state machine. Engage can contain alerted and combat, and alerted can contain investigate and sweep. Each tick of the outer machine evaluates its own transitions first and then passes the tick down to whatever's nested inside of it. So a transition declared at the root gets checked before anything below it, which is how death and stagger are going to interrupt whatever's mid-swing. Combat is just a leaf state. It has no children. It doesn't choose attacks. Its update class or function is just one line that ticks the reasoner. The reasoner is going to go ahead and score 5 actions and run whichever scores the highest. It's, for example, the water jet has 3 considerations: how far away am I, whether I'm past the minimum range, and whether it can see me. So each one is going to return a value between 0 and 1. And distance is really just meters over. It has 120 meter max range, so it just comes out to 30 meters, just comes out to 0.25. And then a response curve is going to map that onto the score. So 3 scores get multiplied together, and multiplying is what makes that visibility a hard requirement rather than a preference. So if the Colossus is not able to see the player, then its visibility is going to be 0, and then that's when that's multiplied by the rest of it, it's going to just take over and kind of normalize the entire thing down to 0. So you can actually watch it decide some things. We'll get in its line of sight. First, let's go ahead and set it to noon. So what we'll kind of notice here is that we're going to be further out, and we're going to see the water jet action winning in the top left. And then as we get kind of closer, the Also, the AI is going to want to advance on us and get within melee range. So let's see this thing working. Right now it's in its passive mode, so it's just kind of scanning around looking. And we'll go ahead and compare its kind of emergent phases due to its health here. So this is its healthy behavior. It's going to want to fire at you, basically just puke up little bouncy balls and close the distance on you. It's going to want to sword because it wants to hit you with its melee. So when we run away, it's going to just pretty much just close the distance, fireballs at us. But we can see what happens when I lower its health with a debug key down. We'll start to see another action start to look very appealing to it, which is it's titled Submerge, but it's functionally a retreat. So this is going to kind of switch up its behavior so that closing the distance and whacking you seems a lot less attractive to this thing than running around, especially when those attacks are on cooldown. And then obviously that weight's only going to increase the lower its health gets. So the more weak this thing gets, essentially, the more preservative it's going to be with its own well-being. So it's just going to kind of try and circle out and get a vantage point here. Get some distance. And then, of course, if it goes all the way down to 0, oh Lord, I think it's stuck in a water jet right now. Goes down to 0, then it just dies as its death state takes over. So that is pretty much it, and I hope you enjoyed the Game AI presentation. So thank you for watching.